All right, well, let's take a look at pyramids and now compute their volumes. So let's start off with an example to get us sort of in the mood. I want us to compute the volume of a rectangular pyramid with length 3, width 5, and height 8. So first, let's just draw a picture of what this might look like. Now again, my picture might not be drawn to scale, but the idea is just to give a sense of what's going on here. So I've got a rectangular base, 3 by 5. This is the back walls, and then it's going to go way up. And so here is my pyramid. See it? This is 3. This is 5. And the height, which means the height from the top straight down, is 8. Okay, so maybe it's not drawn to scale. It could be a perspective thing, but that's going to allow us to actually figure out which part is which. Now, how do you actually compute the volume of this of any kind of pyramid of this sort? Well, the formula is really straightforward. We just take the area of the base, which I'm going to call B, and multiply by the height. That would actually give us the volume of the rectangular prism, but since we want the pyramid, we multiply by 1/3. So it's just 1/3 the area of the base times the height. So for this question, it's really easy to do. The volume is just going to be 1/3 the area of the base, which is 5 times 3, which is 15, times the height, which is 8. And if we simplify that down a little bit, we see this is just 5 times 8 is 40. And what are my units? My units are feet. This is volume, so it's feet cubed. Neat. So you can see the formula in action. Let's try another example. So here we're told that we have a square pyramid. So that means that here the base is a perfect square. We're told that this represents the height. We have this right angle here from the center. We see that's 12. And the question is, what's the volume? Well, we know how to find the volume. It's just 1/3 the area of the base multiplied by the height. What's the area of the base? Well, it's a square, so it's 5 squared. So the volume will be 1/3 times 25 times the height, which is 12. And we can simplify this a little bit. I can make this now a 4, and so I see 4 times 25, and so I see 100. And what are my units? They're inches, but they're inches cubed, because this is, after all, volume. So you can see how easy it is to actually find the volumes of prisms. Of pyramids. What am I saying? Prisms. Prisms are easy. Pyramids. All right, now let's take a look at a really exotic pyramid. This pyramid is pretty cool. Check this out and tell me what you think. I think you might enjoy this. All right, now here, the base of the pyramid is actually a trapezoid. So this is given. This is all given to us now. So in fact, the base is a trapezoid, which I remind you means that this side is parallel to this side. We're told that this length is 8, this length is 5, and this height here is 4. And we're also given something else. This is a perspective drawing of this crazy thing. But we're told that this segment AE, you see that segment right there? That's actually perpendicular to the floor. So it's actually perpendicular to ABCD, the plane that contains all those points, which I'm thinking of as the floor. So basically, AE is sticking straight up like this. Straight up. So really, this is a right angle, and this is a right angle. Why is that relevant? It's relevant because this thing is plainly a pyramid. What's its height? Well, to compute its height, all you do is you go to the very tip top and you draw a perpendicular down to the floor. But we now know what that perpendicular is. That perpendicular is, in fact, AE. And we're given that length is 10. So the height of this thing is 10. So, how do we find the volume? The volume is 1/3 the area of the base times the height. Now, how do we find the area of the base? Well, the area of the base actually is not too hard. Now, you might say, boy, I don't know what the formula is for the area of the base, but if you think about it for a second, you absolutely can figure this out. Let me tell you how I think about it, and then I'll show you the formula. Look, this is almost a rectangle, right? It's not quite, but it's almost. All I've got to do is take this length and that length and average them. If I were to average them, in fact, let me draw you a little picture of this so you can see this live. If I were to average these two lengths, that would fall right in the middle. And look what happens if I were to make a rectangle. Do you see this little surplus here? That would fill in exactly into here because these are congruent triangles. And similarly, this little teeny surplus here would fill in perfectly there. So this rectangle has the exact same area as the original trapezoid because this little piece here can be moved down to here, and this little piece here can move down to here. So, to find the area of a trapezoid, it's almost a rectangle. We just take the average value of this length and that length and multiply by the height. Base times height. Now, how do you write that down for real if you want a formula for it? I would never memorize the formula, but here it is. It's the sum of the two lengths of the parallel sides divided by 2, that's the average part, times the height. In any case, we can now figure it out. So here we go. So the volume of the whole thing is 1/3 the area of the base. The area of the base, we take the average of these two values, 8 and 5. So we take 8 and 5, we add them together, we get 13. We divide by 2, and so we see 13 over 2 times the height, which is 4. So that's the area of the base. Then we multiply that by the height of the pyramid, which, since we're given this very special pyramid, we know the height is the same thing as this length, which is 10. So I put all this together, and what do I see? Well, I can simplify a little bit here. I can see this is just a 2, and so I see a 2 times 13 is 26, times 10 is 260, divided by 3. That is the volume. What are the units? The units are centimeters cubed. Isn't that great? It's so much fun. So even the exotic objects can, in fact,